Happy day, everyone. This is Orekoya Olusegun on Physics Mathematics Fundamental on the YouTube. Today, I want to call our attention to two important aspects of calculus. The first one is basic differentiation. The second one is basic integration. The reason why I'm introducing these two aspects of calculus is that we are going to make use of the process of differentiation and integration in mechanics, especially in deriving the equation of uniformly accelerated motion in physics. So what are these two basics? The first one, which is a basic differentiation, assuming that you are given a function y equal to ax raised to power n, where a is the coefficient, x is a variable, and n is the power. Y also is a variable, but y is called dependent variable, while x is called independent variable. So we want to find the rate of change of the quantity y with respect to x. That is what differentiation is all about. Now, we say, according to the first principle, the y dx, that is rate of change in quantity y with respect to quantity x, is this. Use the power to multiply everything. So it's going to be n times a x, then you subtract 1 from the power, raised to power n minus 1. So this is a basic differentiation. So in differentiation, we are in the process of finding the instantaneous rate of change of a dependent variable with respect to the independent variable. Now, when we move to the basic integration is that if you have been given this particular result we have here is called derivative. Let's say you have been given derivative and you want to find the function y. This y is called function. So in integration, we are given a derivative. Then we want to find the function that leads to this derivative. How do we do it? Let's say the derivative is given as y is equal to as raised to power n. So in integration, we say integral ax raised to power n. While integrating, what we are going to do is to use add 1 to the power and divide our results with whatever we have here. So in a nutshell, we say as raised to power n plus 1 divided by n plus 1. So in a nutshell, then we put what is called an arbitrary constant c. Anytime we are dealing with integration that we are not given the interval of our integration, so it is called indefinite integral. Like for instance, let me just give two examples before we round up. You are given example 1. You are given function y is equal to 3s raised to power 5. Then you are asked to find the y dx. Like what I have told us initially, when you are finding the y dx, we use the power to multiply, then we subtract 1 from the power. So in a nutshell, for this question given here, the dy the x means we use 5 to multiply, so it's going to be 5 times 3, x raised to the power 5 minus 1, and 5 times 3 is 15, x raised to the power 5 minus 1 is 4. So we have gotten our answer. Now let's see an example on that involves integration. The question says integrate 15x raised to the power 4 with respect to x. So like what I said, when we are integrating, we are going to add 1 to the power and divide the result by the new power we have here. Then we had the arbitrary constant. If we have what is called indefinite integral. Indefinite integral is the integral in which the limit of integration is not given. So this question that we have here will now be 15x raised to power, we add 1 to the power plus 1 divided by 4 plus 1. Then we had the arbitrary constant c. So our result will now be 15s raised to power 4 plus 1 is 5 divided by 4 plus 1 is 5 also plus c. And 5 can go through 15. 5 in 15, that's 3. So we are having 3s raised to power 5 plus c. That is the integration. So this is the particular function that when we differentiate it, it gives us this particular derivative. So once again, please like, share and comment on my YouTube. This is Orekoya Fumi Olusegun, Physics Mathematics Fundamental on YouTube. Have a wonderful day. Thank you.